Gasoline is one of the most consumed fuels on the planet. Around 800 million vehicles burn through more than 7 billion liters, nearly 2 billion gallons of fuel every single day. But before it ever reaches a gas station pump, that flammable liquid travels through a remarkably long, complex, and potentially dangerous manufacturing process. Have you ever wondered how gasoline is actually made? Today, we're tracing that entire journey.
From the moment crude oil is pulled out of the ground to the moment the fuel flows into your tank.
Stay with me until the end, because what you're about to discover will change the way you think every time you stop to fill up. Right here on Stories Behind Everything. Gasoline is a liquid fuel derived from petroleum, a complex mixture of lightweight hydrocarbons, molecules built from carbon and hydrogen atoms. It's the fuel of choice for internal combustion engines powering cars, motorcycles, and small aircraft across the world. Humans have used petroleum for thousands of years, but it wasn't until the 19th century that it became a cornerstone of the global economy. Large-scale extraction began in 1859, when Colonel Edwin Drake drilled the first commercial oil well in Pennsylvania.
An event that launched the modern petroleum industry. The invention of kerosene lamps and internal combustion engines
made oil strategically vital for lighting and transportation. Then, in 1908,
Henry Ford's Model T put cars within reach of ordinary Americans, triggering an explosion in gasoline demand
that transformed the industry forever. And during both world wars, oil became a critical military resource, fueling tanks, aircraft, and warships, and shaping the outcome of global conflicts. But before a single drill touches the ground, someone has to figure out where the oil actually is, and that's harder than it sounds.
Oil doesn't pool in giant underground lakes waiting to be tapped. It hides inside porous rock.
Miles beneath the surface, invisible and silent. To find it, geologists study ancient rock formations and sediment layers,
looking for the geological signatures that suggest hydrocarbons might be present.
Travel deep underground and bounce back when they hit different rock layers.
Sensors on the surface catch those returning signals and translate them into detailed 3D maps of what lies beneath.
It's like giving the entire planet an MRI scan. If those maps show a promising structure, exploratory drilling begins.
Though even with all this technology, striking oil is never guaranteed. Every well drilled is still, at its core, a bet. When an exploratory well strikes oil, the crude is sent to a refinery where it will be processed into gasoline, diesel, jet fuel, and a wide range of other products, including plastics, asphalt, tires, cosmetics, and even pharmaceuticals. Getting to the oil is a feat of engineering that most people never think about. The drill doesn't just punch straight down like a nail. Each section of drill pipe is about 33 feet long, and depending on what the bit is cutting through, it can take anywhere from 20 minutes to over an hour, just to drill through a single section. When one section is done, the entire drill string is raised, a new pipe section is bolted on, and the process starts again, repeated hundreds of times,
before the well reaches its target depth. As it goes deeper, steel casing pipes are cemented in place
to stabilize the walls and keep different geological zones from mixing. Throughout the entire process, a specially formulated substance, called drilling mud, is continuously circulated through the well. This fluid lubricates and cools the drill bit, carries rock cuttings back up.
When reservoir fluids escape to the surface in an uncontrolled rush, potentially triggering fires, explosions, and severe environmental damage. It's a slow, methodical process. But the payoff, when it comes, is worth every inch. Once the target depth is reached, the well is tested. Pressure readings, temperature measurements, and fluid samples are analyzed to confirm the presence and quantity of hydrocarbons.
If the results are positive, production begins. In the early stages, the natural pressure of the oil trapped deep underground is enough to push it up the production pipe to the surface on its own. When that pressure eventually runs out, pump jacks are installed. Those iconic rocking structures you see dotting oil fields across Texas and beyond.
They work with a back-and-forth motion, creating suction that draws oil up from the depths. Like a giant metal syringe pulling liquid from the ground. Pipelines connect individual wells to a main line.
What remains is raw crude oil, ready to travel. In Brazil, most production happens offshore.
The crude moves through underground pipeline networks, stretching up to 600 miles.
Pumped continuously, day and night, until it reaches the refineries where the real work begins. Threaded with thousands of miles of pipework, capable of processing 600,000 barrels of crude every single day. Before refining begins, specialized equipment strips out hydrogen sulfide from the crude and converts it into elemental sulfur, which is then sold to farms as fertilizer. Nothing goes to waste. This is where the real transformation happens. The distillation tower is the heart of the refinery. A towering column where crude oil is literally taken apart and rebuilt into the products that power the modern world.
Separating out like layers of a cake. The heaviest compounds, the ones destined to become asphalt and heavy fuel oil.
And near the top, where temperatures are lowest, the lightest molecules condense into gasoline. From a single barrel of crude, refineries extract roughly 19 gallons of gasoline,
10 gallons of diesel, and 5.5 gallons of jet fuel, along with plastics, lubricants,
tentinants, and dozens of other products we use every day, without ever thinking about where they came from.
Octane measures the fuel's resistance to knocking, a phenomenon where gasoline ignites too early inside the cylinder.
The test results are fed back to the refinery in real time, and if the fuel doesn't meet the standard, it goes back for adjustment.
Only when it passes does the gasoline get cleared for distribution. With quality confirmed, valves open,
and the gasoline flows through underground pipelines to loading terminals, where the final and perhaps most dangerous leg of the journey begins. Filling a tanker truck is far more hazardous than pumping gas into a regular car. The metal body of the truck builds up static electricity during loading, and a single spark near gasoline vapor can trigger a catastrophic explosion. To prevent this, tanker trucks are fitted with grounding cables that discharge static buildup, and overflow sensors that cut the flow the instant a tank reaches capacity. A secondary pipe system, the vapor recovery line, captures gasoline vapors released during loading, preventing them from drifting into the atmosphere. Every day, around 1 million gallons of gasoline roll out of refineries across the country on tanker trucks. When a truck pulls into a gas station, its hoses lock onto the underground storage tank inlets. Valves open, and gravity does the rest. The fuel flowing silently down into the tanks below. The next time you pull up to a pump and squeeze the handle, that fuel has already crossed hundreds of miles, passed through fire and pressure and chemistry,
and made it to you.
If you enjoyed this episode, drop a like, share it with your friends, and leave a comment telling us where you're watching from.